Welcome to Python Break Statement, a beginner's complete guide. Have you ever needed to stop a loop early before it finishes all its iterations? That's exactly what the break statement does in Python. Think of it like an emergency exit door in a building. You normally walk through room by room, but if you spot something urgent, you head straight for the exit without finishing the tour. In this video, you'll learn everything you need to know about break, what it is, how it works, when to use it, and most importantly, when not to. Let's dive in. What exactly is the break statement? Break is a single keyword that immediately stops a running loop. The moment Python sees break, it exits the loop and continues with whatever code comes after it. It works in both for loops and while loops, making it a versatile tool for controlling loop execution. Think of it as an emergency exit. You normally process items one by one, but when a certain condition is met, you can exit immediately without processing the remaining items. This makes your code more efficient and gives you precise control over when loops should stop. Let's start with a simple example. We have a for loop that's supposed to iterate from 0 to 9, but we've added a condition. If the number equals 4, we break. Watch what happens as the code executes. The loop prints 0, 1, 2, and 3. Then, when number becomes 4, the break statement fires, and the loop stops immediately. Notice that 4 itself never gets printed because break happens before the print statement. This is the fundamental behavior of break. It exits the loop at that exact moment, no matter how many iterations were originally planned. Here's exactly how Python processes a loop with break step by step. First, the loop starts and picks the first item from the sequence. Second, Python checks your if condition. If the condition is false, it runs the loop body and moves to the next item. But if the condition is true, it hits break and exits the loop immediately. Finally, Python jumps to the first line of code after the loop. This flow is important to understand because it shows that break doesn't just skip an iteration. It completely terminates the loop and transfers control to the code that follows. Here's a real-world example. Imagine you have a list of orders to process, but one of them is marked as canceled. You want to stop processing the moment you hit the canceled order because any orders after it shouldn't be processed either. Watch as the code iterates through the orders. It processes order 1 and order 2 normally. Then it encounters the canceled order, prints a message, and breaks out of the loop. Orders 4 and 5 are never processed. This is clean, simple, and efficient. No need to waste time on items that come after a stopping condition. Break is just as useful in while loops. Here's a classic example. A simple guessing game. The loop condition is always true, which would normally create an infinite loop. But we use break as the exit condition. When the player guesses the secret number correctly, we print a success message and break out of the loop. Without break, this loop would run forever because the condition never becomes false. The break gives us a way out once the winning condition is met. This pattern is common in games, user input validation, and any situation where you need a loop that runs until a specific event occurs. This is one of the most common points of confusion for beginners. Both break and continue change how a loop behaves, but they do very different things. Break exits the loop completely. Continue skips just the current iteration and keeps going with the next one. Look at the comparison on screen. With continue, when I equals 3, that iteration is skipped, but the loop continues and prints 4 and 5. With break, when I equals 3, the entire loop stops and only 0, 1, and 2 are printed. Use the wrong one, and your program will behave in unexpected ways. Remember, break means stop everything. Continue means skip this one and move on. When you have a loop inside another loop, break only exits the inner loop, not both at once. This is crucial to understand before working with grids, tables, or any nested data. Watch what happens in this example. We have an outer loop for rows and an inner loop for columns. When column reaches 2, the inner loop breaks, but the outer loop keeps running, moving to the next row. That's why we see row 1, column 1, row 2, column 1, and row 3, column 1. Each time the inner loop breaks, control returns to the outer loop, which continues its iterations. If you need to exit both loops, you'll need additional logic beyond a simple break. Python has a feature most other languages don't, an else block on loops. This else block runs only if the loop finished without hitting a break. It's a very clean pattern for search operations. Watch this example. We're looking for cheese in a shopping list that contains milk, eggs, bread, and butter. The loop checks each item, but never finds cheese. Since break never runs, the loop completes naturally, and the else block executes, telling us that cheese is not in the list. If cheese had been in the list, break would have fired and the else block would have been skipped. This pattern makes search logic very readable and explicit. One of the most common uses of defect is in searching. Here, we're looking for the first temperature that exceeds a threshold of 40 degrees Celsius. The loop checks each temperature in order. 22, 35, and 19 are all below the threshold, so the loop continues. But when it reaches 41, that's above 40, so we print the result and break immediately. Without break, the loop would keep checking the remaining temperatures even though we already found what we were looking for. That's wasted work, especially with large data sets. Break makes your search operations efficient by stopping as soon as you find a match. Here's a common pattern you'll see in real programs. Keep asking the user for valid input until they give it. We have a list of valid choices: rock, paper, or scissors. The loop runs forever with while true, but the break is the only exit point. If the user enters something invalid like Spock or lizard, we print an error and the loop continues, asking again. Only when they enter a valid choice do we print their selection and break out of the loop. This ensures your program only proceeds with valid data. The break is essential here because it's the controlled exit from what would otherwise be an infinite loop. Let's combine break with the loop else pattern to check if a number is prime. A prime number has no divisors other than 1 in itself. We loop through all numbers from 2 to n-1, checking if any of them divide n evenly. If we find a divisor, we break because the number is not prime. The else block only runs if the loop completes without breaking, meaning no divisor was found and the number is prime. Watch the examples. 7 has no divisors, so the else runs and returns true. 10 is divisible by 2, so we break and return false. This is a neat and readable approach to prime checking. Break is useful, but it can be overused. Watch out for these situations. First, multiple breaks in one loop create too many exit points and make code hard to read and debug. If you find yourself adding break after break, consider restructuring the logic or using a function with return instead. Second, be careful about breaking with side effects. If your loop modifies data, breaking early might leave things in a half-updated state. Always think about what state your program will be in after the break. Best practices include using break for early exit when you find a match, preferring return in functions for complex logic, and keeping loops with a single clear exit point when possible. Here's a quick reference for the most common break patterns. For basic break in a for loop, use break inside an if condition to exit when a condition is met. For while loops, the pattern is the same. For break with else, remember that the else only runs if break never happened. And for infinite loops, use while true with break as the controlled exit point. Keep this reference handy as you write your Python code. Break is a simple but powerful tool when used correctly. Congratulations! You've mastered the Python break statement. You now understand how to stop loops early, the difference between break and continue, how break works in nested loops, the unique loop else pattern, and when break is the right tool for the job. Remember, break gives you precise control over loop execution, making your code more efficient and readable. If you found this tutorial helpful, please like and subscribe for more Python content. We have many more tutorials coming soon, covering continue, pass, while loops, and advanced Python concepts. Happy coding, and see you in the next video.